Just as subtraction led to a new set of numbers, negative integers, division leads to a new set of numbers called fractions. This results when you ask questions like, what is 1 divided by 2, 1 divided by 3, 2 divided by 3, 1 divided by a million? These answers are not so clear. 1 divided by 2 asks the question, if I divide 1 into 2 equal pieces, what will be the size of each piece? The answer to this question cannot be found in the integers. New numbers were needed. There are an infinite number of fractions between each pair of integers, since the space between any two integers can be divided by as large a number as you can imagine. On the next slide, a few are shown, but in reality, there are as many fractions between any pair of integers as there are integers. Fractions can be written as a ratio of two numbers. For example, negative 2/3, negative 1/4, negative 1/8, 1 over 3, 4 over 5, 7 over 5, 80 over 4, etc. You can keep having the ratio of any two numbers that you want or that you can think of. Again, there's an infinite number of fractions. You can also have them in decimal form by dividing the numerator by the denominator. For example, negative 0.6 repeating, negative 0.25, negative 0.125, 0.3 repeating, 0.8, 1.4, 20. 20 is technically 20.0, right? You can turn any integer into a decimal by adding a 0.0 to the end. And that bar over 666 and 333, that means it repeats forever. That's why I used the term repeating when I read that number. There are an infinite number of fractions between each pair of integers, as we mentioned before. Using a magnifying glass to look closely between 0 and 1 on this number line, we can locate a few of these fractions. So right now our number line was between negative 10 and 10, so we're zooming in again between 0 and 1. Notice now that we're zoomed in from 0 to 1 that it's easier to find their location when they are in decimal form, since it's clear which integers they're between and closest to. So for example, the fraction of 1/2, if we do 1 divided by 2, its decimal equivalent is 0.50 or 0.5. It's a lot easier to locate 0.5 to see it's right in the middle of 0 and 1. We can do, for example, 4/5 or 4 divided by 5.8 is going to be closer to 1 rather than 0. So we can look at all of these examples, right? There's an infinite number of fractions in between 0 and 1, but these are just a few examples to see on the number line. Rational numbers are numbers that can be expressed as the ratio of two integers. Before, we just had the ratio of two numbers as a fraction. Here, rational numbers include the integer piece. This includes all fractions as well as the integers. What are a few ways you could write 5 as a ratio of two integers? Right? We can turn 5 into a decimal as having 0.0, but 5 can be rewritten as 5 over 1. We could have 50 over 10. We can have 25 over 5. Since the fraction bar is signifying division, you really can have anything that simplifies to 5. You can have 10 over 2. Anything, there's an infinite amount of ways if you think about the two integers that simplify to 5. Fractions can be written in fraction form or decimal form, as we saw before. When written in decimal form, rational numbers are either terminating, such as 1/2 is 0.05, and we don't include all these extra zeros. So that's why it just stops at the first non-zero number of 0.5. Or repeating, such as 1 over 7 is 0.142857, 142857, and it repeats that pattern. So we just include all the non-zero numbers that repeat in a pattern. Or 1 over 3 is 0.3333333, and just the 3 is repeating. And we have a couple of the digits, usually 3 to signify. When we have a negative fraction, the negative sign can be in different places. We can have negative fractions just like we can have negative integers. The following are all equivalent to negative 1/2. Why are they all negative? Take a moment and think about our shortcuts with division, because the fraction bar signifies division. When dividing a positive by a negative or a negative by a positive, your answer is negative. So here we have -1 divided by a positive, and here we have 1 divided by a negative. So your answer is going to be negative. A number is also negative if you perform the operation of division and then make the fraction negative. So here 1 divided by 2 would be positive, but then we're making it negative. Same thing, 1 divided by 2 would be positive, but we're making it negative. And 1 divided by 2 is positive, and then we're making it negative. So they are all negative fractions. These fractions equal positive 1/2. Why are they both positive? Again, we have to think about our shortcuts with division, because the fraction bar signifies division. When dividing a negative by a negative, your answer is positive. So here a negative divided by a negative. But a negative can also be considered the opposite sign of the original number. So the opposite of negative 1/2 is going to be positive 1/2. They are both, again, positive, giving us positive fractions. One number that is not defined by our numbers and our mathematical operations is dividing any number by 0. The result of that division, we say, is undefined. For example, things like 3 divided by 0, a negative integer divided by 0, such as -5, or even 0 divided by 0, we would all say is undefined. This will be critical later when we are working with equations and simplifying fractions. Dividing by 0 is undefined since there is no way to say how many times can 0 go into any number.